We're going to talk about a converse. A converse, not the shoe, but a converse statement. So it's a converse is kind of like an inverse or kind of like a reverse, like they kind of all have that same idea. A converse is really just something where we're going to sort of flip-flop. So far this chapter, you've completed several problems in which you were given some information and had to determine whether the triangles were congruent. That's what we were just doing. But if you already know the triangles are congruent, what information could you conclude then? Okay, so if we already know, hey, they're equal, then what else do we know about them? So thinking this way requires you to take your triangle congruence conjectures and reverse them. Okay, so we're going to talk about that more and more as we go along. So first we're starting here. We've got George is working with the diagram at the right, and he concludes that AB is parallel to CD. So based on this information, he knows these lines are parallel because he knows that these angles are in fact equal. So he says, if the alternate interior angles are equal, then the lines are parallel. Okay, we kind of have used that information before. So Margaret is working with a different diagram. She already knows that her lines are parallel, and she wants to say, or wants to conclude, that x is equal to y. Do we have enough information to say that? Yeah, and that takes us right back to what we were just doing in our flow chart. We know that those have to be equal. Let's see here, grab a color here. Write a conditional statement or arrow diagram that justifies her reason. Well, we started with, she was given some information. She knows that if the lines are parallel, just like we saw in our flow chart just a second ago, then the angles, and these specifically, these are our alternate interior angles, interior angles, have to be equal. And we use that in our flow chart, equal. So she started with parallel lines and was able to conclude the angles were equal. George started with equal angles and was able to conclude that the lines were parallel. How are their statements related? How are they different? Well, if we look at the words, we have, let me move that, there we go. Alternate interior angles are equal. The lines become parallel. Well, when we look at our statement, we have started with the lines are parallel and we end with the alternate interior angles are equal. It's the same words, they're just reversed. So they're the same words, but they're backwards or reversed. So conditional statements that have this relationship are called converses. Not the shoe, but they're just like the reverse or the inverse, they're the opposite. Okay, just like subtraction is the opposite of addition, a converse is the opposite of a regular statement. So now we're going to do this. We're going to say, okay, here's a statement. If lines are parallel, then corresponding angles are equal. So we want to write the converse. So what I'm going to do is I'm going to take the part at the end, and this one moves to the front. I don't take the then, I just take the part after the word then. So that's going to move to the front, and then the lines are parallel moves to the end. So I literally am just flip-flopping the statement. That's all there is to it. So let's see here. We'll say if, so I'm still going to start with that. A conditional statement always starts with an if followed by a then. So I'm going to say if corresponding angles are equal, angles, and then I'll move the part that was originally in the beginning to the end. And that's all we do. So we're just flip-flopping this around to make a converse statement. Like I said, these ones are going to go really quick because it's literally just that. That's all we're talking about. That's the whole point. So I've got a couple more of these, just trying to see how they look. It says in the previous problem, you learned that each conditional statement has a converse. Are all converses true? Consider the arrow diagram of a familiar conjecture below. So we know triangles congruent, arrow. So basically it says if triangles are congruent, arrow means then the corresponding sides are congruent. So if the triangles are equal, then all of the sides are equal. Is that true? Yeah. If they're equal, then all of their sides are equal. So then it says write the converse of this as an arrow diagram or a conditional statement. Because I'm typing, I think it's going to be easier for me, or because I have, I'm at the computer, I'm going to go ahead and just type it as a conditional statement. Come on, maybe. It's thinking about it. Try it again. There we go. If, let's see here, corresponding sides are congruent, then the triangles are congruent. I'm going to add a couple of words there just to make it so that the sentence makes sense. You can write it as an arrow diagram as well. That's totally fine. I don't know why my mouse is just not, I think I need to recharge my mouse. I think that's the issue. So the question is the converse of this true? If the sides are congruent, are the triangles congruent? Yeah. Because that's our side, side, side congruence method. That's one of the ways we know that triangles are congruent. It's one of our shortcuts. So now we have basically the same thing. It says, consider another true congruence. If the triangles are congruent, then the angles are congruent. And this, again, will tie right into something we talked about. So if the triangles are congruent, then the angles are congruent. So we're going to write its converse to start with. So basically the same thing. It's the same, almost the same sentence that we just wrote. I don't know why my, here we go. If corresponding angles are congruent, then, so again, we're just taking what's at the end and we're moving it towards the beginning. And we're taking what's at the beginning and we just move it towards the end. Okay, so there's our statement now. Yep, something's wrong with my mouse. It moves, but it's not actually letting me click. All right, so here again, just to show you, this part moved to the beginning. This part moved to the end. So the question is the converse true? If the angles are congruent, is that enough to say the triangles are congruent? So is there an AAA congruence for triangles? No. There's not an AAA congruence method. We have an SSS, but not an AAA. We have an angle-angle side method, but we need to have the side as well. All right, so the last one here, just looking at some more of these, we want to write the converse. So it says, consider it. It says the shape is a rectangle. The area of the shape is base times height. That's true. We know if you have a rectangle, the area formula for a rectangle is base times height. We want to write the converse. So we're going to take what's at the end and we move it to the beginning. And we take what's at the beginning and we move it to the end. So to start with, let's see here. What color should I use now? I know. I'm going to use pink. Why not? So you can write it as an arrow diagram. It's just harder for me to do that on the computer here. So I'm going to write if the area of the shape is base times height. And so then we take the part that's at the beginning and we move it towards the end. Then the shape is a rectangle. You can change the words a little bit as long as you don't change the overall meaning. So I'm just taking the word and changing it to an the, that kind of stuff. You can do that. So the question is that true? If the shape, the area is base times height, is the shape a rectangle? Sometimes yes, right? A rectangle is, right? If we think about that, we can do base times height. That's our area. Could it be a square though? Or, so this is where we're talking about these, is it true or false kind of deal. Can you come up with a reason why it might be false? So is it true always? Not always. Sometimes it's true, but not always, because it could be a parallelogram or a square. And its formula would still be base times height. And that's all that one is. And that led us right to the end of the hour. So apologize for that. But I knew that the flowcharts were going to take us a little bit longer. Oh, which means that I didn't. Maybe we'll do that then. Yeah, so here I have the last part of the blue sheet. I will post this online. I'll fill this out and I'll post this online too if you want to stick around. I mean, I know we only have like 30 seconds left, but if you want to go ahead and fill that out now, you can. Otherwise, I'll post it online for you with all of that completed so you can see, some of your different methods for your converses. So there's your blue sheet. And your homework tonight, we have 4 problems of flowcharts. So make sure you use the notes that we took to practice those. And then we have the 614, which has a bunch of these, just writing your converses with a couple extra review questions. So should be pretty short for homework, due Wednesday. Any questions? Are we good? You guys are free to go. Have a great day.